This video is being created to show you the titration curve of a diprotic acid with a strong base. So what we're going to do is we're going to determine the pH, and we're going to graph the pH versus volume when a 0.1 molar solution of sodium hydroxide is added in 20 milliliter increments to 50 milliliters of a 0.1 molar H2SO4 solution. So right here, these are the volumes that we're going to add, and we're going to calculate the pH along every step of the way. So one of the first things to do when we are doing a problem like this is we need to write the balanced equation. So we'll start with that. So we have H2SO4, okay, sulfuric acid, that we are going to add sodium hydroxide to. Okay, now all of these are aqueous, I'm just not going to put those in. The products of this reaction are going to be water and sodium sulfate, Na2SO4, which that would be an aqueous salt. Now, one of the things that we need to do is we need to balance this equation because we have two NAs here, so we need to put a 2 in front of the NaOH. And we have a total of 4 hydrogens, which means we're going to need to put a 2 in front of the H2O. And that pretty much balances our reaction. So the thing to make note of here is our acid to base ratio. We have a 1 to 2 mole ratio for the acid and the base, and that is going to be significant. Okay, so one of the first things that we'll do is if we just take this and calculate the pH of that solution without any added acid to it, the pH of a 0.1 molar H2SO4 solution is actually going to be a pH of 1. Okay? Now, what we're going to do is I'll go and we'll make calculations for adding everything else. What I will do is when we're all done is then I'll graph everything. So I've already created a graph on this page, but I'm going to make all the calculations and then we'll come back and we'll worry about graphing it. Okay, so what we'll do is I'm just going to slide down here. I want to start with a kind of blank slate. And we are going to add then the 20 milliliters of 0.1 molar NaOH to the 50 milliliters of 0.1 molar H2SO4. Okay? So we'll just look at what happens when we do this. Now, if you remember where we were doing our previous reactions, all that really matters is what the reactants are doing. So all I'm going to worry about is the H2SO4 and the 2 NaOH. Okay? Yes, this yields something, but we never cared about that. And we are going to create our mice chart just looking at that. Okay? Now, some things that we need to deal with initially is we need to know what our initial moles of H2SO4 are. So we can do a quick side calculation. We have 0.1 mole per liter of the H2SO4, and we have 0.05 liters of that. So that math means I have 0.005 moles of H2SO4 to start with. So my moles initial of H2SO4 are 0.005, and that number is never going to change. I will never have to recalculate that because we are always with that volume, okay? What is going to change each time is my moles of NaOH, okay? So I have 0.1 mole of NaOH per liter, And I'm going to start with 0.02 liters of that. That means I'm starting with 0.002 moles. Okay? So my initial concentration of NaOH is 0.002 moles. Okay? Now, one of the next things to think about is which of these is going to be my limiting reactant and how much. But we also need to consider the fact that this is a 1 to 2 mole ratio. So I cannot, and I'm going to delete this, I cannot just say, well, this is going to disappear by 0.002 and this is going to disappear by 0.002. That doesn't happen because that only happens in a 1 to 1 mole ratio. Okay, so what I have to do is figure out what is going to be the limiting reactant. So I need a separate kind of side calculation for this. So what I got to do is I got to take my 0.002 moles of NaOH, and I need to figure out how many moles of H2SO4 it will react with, which means I need to do a stoich problem. So I'm just going to do a mole-to-mole stoich problem where I have 1 mole of H2SO4 for every 2 moles of NaOH. My moles of NaOH will cancel, which means I'm only going to use up 0.001 moles of H2SO4. Okay, so you see that? This 0.002 moles of NaOH only uses 0.001 moles of H2SO4. So this is going to completely disappear and go to 0. But this is only going to disappear by 0.001 moles. That means you have 0.004 moles left over. Okay? Now, I need more space, but this is my moles of H2SO4, and what I need to do now is determine, okay, what will be my new concentration. So, the moles of H2SO4 is 0.004 moles, and that 0.004 moles is in the 50 milliliters that we started with plus the 20 milliliters that we just added. So, to find the molarity, I need 0.004 moles divided by that 70 milliliters, which is 0.07 liters, so divided by 0.07 liters. Okay, and that's going to give me my molarity. And that molarity, if I did my math right, is 0.057 molar. And then from that, I can now calculate my pH. So my pH is going to be minus the log of 0.057. So my pH comes out to be 1.24. Okay? So, at 20 milliliters added, I get a pH of 1.24. So maybe I can just, at 20 milliliters, so at 0 milliliters we're at 0.1. At 20 milliliters, okay, and I'll just start a little tab column here. 20 milliliters is 1.24. Okay? And that's our first step. Now we need to go to 40 milliliters. Okay? So I'm going to go to a whole new blank page. So now I'm going to add 40 milliliters of 0.1 molar NaOH. Okay? And we're going to start with our mice chart, which is H2SO4 plus 2 NaOH. The H2SO4 is always 0.005 moles. That will never change. But now we have 40 milliliters, so 0.04 liters, I'm doing this backwards, sorry, times 0.1 mole per liter of NaOH is going to give me 0.004 moles. So, my initial moles is 0.004 moles. But I have the same stoic issue. I still have a 1:2 mole ratio. So, I am not going to subtract 0.004 from this side. I have to calculate how much is going to actually disappear. So, 0.004 moles of NaOH times a 1:2 mole ratio, 1 mole of H2SO4 for every 2 moles of NaOH. I wish I had more board, but that cancels, and that leaves me with 0.002 moles of H2SO4. So, this is all going to decrease because we used it all up right there. So that goes to 0, but this is only going to decrease by 0.002 moles, which means I have left 0.003 moles. Well, that 0.003 moles is now in the original 50 milliliters plus the 40 milliliters. So this is 0.003 divided by 0.09 liters. And my math calculations, I went straight to pH. So my pH for this is 1.47. Okay? I guess I could do this way. 0.003 divided by 0.033 molar is what that came out to be. Okay? So, that was 40. And I'm not going to go to my chart, I'm just going to keep going on. So now we're going to go add 60 milliliters, 0.1 molar NaOH. Okay? Mice chart. H2SO4 plus 2 NaOH. This is still 0.005. Okay? And now I have 0.1 mole per liter of the NaOH times 0.06 liters. And hopefully you can start seeing, what is actually going on here. Okay? This is now 0.006 moles, right? So you can see that we're going up by 2/200ths of a mole every time, 2,000ths, I guess. So this is now 0.006 moles. But again, this isn't a limiting right here, okay? That doesn't change who my limiting and excess reactants are, because this 0.006 moles of NaOH is still got to be times this 1:2 mole ratio. 1 mole of H2SO4 to 2 moles of NaOH. Okay, and just doing the math in our heads, we see that that comes out to be 0.003. So, this does all decrease. Again, we used it all up right there. So that's the 0. but this only decreases by 0.003. So that leaves me with 0.002 moles left. And again, now what's that 0.002 moles in? That is in the original 50 milliliters plus the 60 milliliters. So now we're at 110 milliliters. So 0.002 divided by 0.110 liters, okay, is going to give me, did I write these moles down? 0.081 molar and pH of 1.74. So if you're looking at our pHs, we're not changing pH by much. Okay, we're adding a significant amount of base, but our pH is not changing. So what's the next one? 80 milliliters.